So in this Khan Academy module, we're trying to use algebra to recognize if our system has one solution, no solutions, or infinite solutions. This doesn't mean we have to solve for the variables. It means we have to recognize if one of these three situations exist. Let's try the first one. So we have negative 3x minus y, right, equals negative 6, and then x minus y equals 1. I'm going to rewrite the second equation, right, by adding y to both sides. So I get x equals y plus 1. On the left-hand side, when I add y, that cancels out. I already have a negative y there. On the right-hand side, we had a 1. Now we're adding y. This means I can use substitution to solve this problem. X equals y plus 1 plugs nicely into the other equation. So we get negative 3 times y plus 1 minus y equals negative 6. So we distribute the negative 3, we get negative 3y plus negative 3, right, minus y equals negative 6. And here you can already recognize the answer. What I mean is, we know that as we move forward, you're going to get a number value for y. That is the first part of the point. That is the solution for these two equations, right? These equations can be thought of as lines on a graph. So when you start to solve, you're finding a y and x value of the point, right? The point is point xy, wherever it lives, where these two lines meet, right? There's some line, let's say here. Oops, that's terrible. That's some line maybe this way and another this way that crosses this point somewhere. You're trying to find that point. If the point has a y value, a number, it must also have an x value. Here's what I mean. If we solve this, we get negative 3y minus y, that's negative 4y, plus negative 3, that's a minus 3 equals negative 6. You can keep going. If we add 3 to both sides, we get negative 4y equals what? Well, negative 6 plus 3, that's negative 3. And then divide both sides by negative 4, and y equals 3/4. So in this case, our point has a height of 3/4. Right? So let's pretend this height right here is 3/4 on the y-axis. We plug this y value back into either equation to get the x value. So for example, x equals y plus 1, right? So if y is 3/4, then x equals what? Well, 3/4 plus 1. So that means the point is where x equals 1 3/4 and y equals 3/4. That's a point over here, let's say. So our two lines cross, let's say, this point. I'll move it further over to the right here. This point right here, we have two lines crossing it. I'm not even thinking about the shape of the line, I just know there are two lines crossing. So as soon as you begin to solve in this module and you realize that the x or y has a value, then you know you're finding the one point where these two things cross each other. Now, you might feel a little odd about that because perhaps you're thinking of infinite solutions where you have two coexisting lines. But let's look at some of those situations to understand what's going on here. Determine how many solutions exist for this system. So we have negative 6x plus y equals 7. And the second equation, negative 12x plus 2y equals negative 18. You might recognize here that the answer is there are no solutions, right? The way I recognize that is by realizing, that we have negative 6x plus y equals 7 in the first case. And the second equation is negative 12x plus 2y equals negative 18. And one thing I start to look for is this equation just a scaled up version of the other one? And what I mean is, I notice that negative 6 here, the coefficient of x, goes into negative 12, the coefficient of x here. I know that if I double negative 6, I get negative 12. So I'm thinking, what happens if I double everything in this equation? What do I get? If I double everything, I get negative 12x, right, plus 2y equals 14. So I haven't changed anything in this equation. I just scaled everything up. It's kind of like having 1 plus 2 equals 3. And then saying if you double everything, that's like having 2 plus 4 equals 6. That's still true. You have a different numbers that you're plugging in, same equation. The equation represents a balance between two quantities, and we haven't changed that. So if I backtrack a little bit, this means now that I have two equations, right? Negative 12x plus 2y equals 14, and then the same thing, negative 12x plus 2y equals negative 18. In other words, we have negative 12x plus 2y equaling two different things, 14 and then negative 18. That can never happen, right? Is it ever possible to add two numbers, this is a number, and get 14, and then add the same two numbers and get a different result? No, this cannot happen. And if you went further and to solve it, this is not enough to convince you. At this point, since you have two equal x's and y's, you can subtract one from the other to really see what's happening. Excuse me. So negative 12x minus negative 12x, that's negative 12x plus 12x, that's 0x, or just 0, right? And 2y minus minus 2y is also 0. So we have 0. On the right-hand side, 14 minus negative 18 is like 14 plus 18, which is 32. And we get a situation like this. 0 equals 32. If you get this kind of an imbalance, right, 0 does not equal 32. If you get something like this, you also know this means there are no solutions. So two ways to tell if there are no solutions are, if you have two equivalent expressions equaling different values, there are no solutions, right? If you have tried to balance the equation and you get a result like one number equals a different number, which can't happen, you know there are no solutions. And here, the other situation is that there are infinitely many solutions. So let's look for one of those. So let me see if I can find, if I have one here in my choices. So here, I think we have one. And it's hard to recognize at first. But if I was to move things around the second equation says y equals 10 plus 3x. If I subtracted 3x on both sides, well, I'll show you here. Y equals 10 plus 3x. If I subtract 3x on both sides, I get negative 3x plus y equals 10. Now, with negative 3x plus y equals 10, it's kind of like each term is half of the other expression, which is negative 6x plus 2y equals 20. If I double everything, here I get negative 6x plus 2y equals 20, so I get the exact same equation, just written in two different forms initially. That means these things always have a common solution, so it's infinite. And if you don't see this, like this requires you to manipulate and see that one is just a scaled up version of the other. Remember before, when one of the expressions equaled 20, let's say, and if this one equaled 40, if you have the same expression equaling different things, that would mean no solutions. But if you have the same expression equaling the same value, that is always true, you have infinite solutions. If you don't see that, you can try using elimination or substitution to see what's happening. So let's try that really quick here. We have y equals 10 plus 3x. In the other equation, we have negative 6x plus 2y. Well, I'll plug in 10 plus 3x for y, and that equals 20. So if we simplify this, we get negative 6x plus 20 plus 6x equals 20. 6x and negative 6x is 0. We get 20 equals 20. We can try subtracting 20 from both sides or do whatever at this point, because now both sides of the equation are always going to be equal. This is always true, so the answer is always true. So to recap, if you get something that's always true, like 20 equals 20, there are infinite solutions. Or it means one equation is a scaled up version of the other. If you have two equal expressions that equal different results, like this one, right? Or you solve it and get an impossible result like 0 equals 32, there are no solutions. And if you start to solve it and get a number value, like x equals, or y equals 3/4 and x equals 1 3/4, that's the one point where these two lines cross. Thanks.